All right, we're going to get started. Welcome to Design at Large. I'm Stephen Dow, and our speaker today is one of our own. Philip Guo is an assistant professor in cognitive science, and before he came to UCSD, he was a professor at University of Rochester. He actually just arrived on campus in July, and before he was a professor at Rochester, he was a postdoc at MIT. And then before that, he was a PhD student in computer science at Stanford. And Philip is perhaps best known for a memoir he wrote at the end of his PhD called The PhD Grind. That's very widely read and really captures the intellectual journey and emotional experience of being a PhD student. So if you are a PhD student, it would be a fun thing to read. And Philip's research, and I think his talk today is going to focus on his work enabling people to learn how to program. And he currently has a tool called Python Tutor. It's an online tool to help people learn to program, and it's been used by 2.5 million people, and 20 million pieces of code have been written through his tool. So very successful. So let's give Philip a warm welcome, and thank you for joining us at UCSD.
Thank you. Alrighty, so I'm supposedly a local speaker since I came down just 1,000 feet from CogSci. But this work is actually done all in a whole other, I guess, planet in a way. So this is work that I did when I was in Rochester. This is Rochester in June, I think, June or July. This is the computer science building.
What's the white stuff?
I think it's the glare on the camera or something. There's some glare. So this, I spent 2 years, my first 2 years, an assistant professor at the University of Rochester. I had an awesome time there, and even despite the snow. And the talk I'm going to be giving today is basically off of work that I did while being snowed in all year. So I'll give you a brief rundown of my day. This is my apartment, and you get these icicles that are like bigger than, taller than a story. One of the icicles actually fell on the roof and like leaked through the roof. I've never been icicled before, but now I know what that is like. Daily drive to work, I would get out and I would shovel snow from the car and from the tires and try to get out there. After you park in the parking lot, you have to walk to school across like a thing that's like, this is like as high as people of ice. And then at the end of the work day, once you're done doing all your work, you go and try to find your car in the parking lot and dig your car out. So needless to say, I'm pretty happy to be here. So the work I'm doing today, that I'm talking about today, is kind of getting at this really big sort of issue, which is that, as all of you know probably here, that computer programming and data science are vital skills across a ton of professions, right? So anywhere from being a software engineer, which many of the CS majors and other majors here are aspiring for jobs in software engineering, software development. These are awesome jobs. You can get a ton of jobs here and elsewhere. But beyond just doing software engineering, there's a lot of rules for what's increasingly called data science. It's basically writing code to analyze data. So this is Indeed.com. It's one of the big job posting sites, and it's just shown that the term data scientist is just kind of exploding. This is not news for anybody who's been following the job market. Data science has kind of been used for many years, right? Even before this whole movement. So this is one of my friends, Kevin, who's actually a UCSD alum, and he's an oceanographer, an ocean engineer, and you think that he spends most of his time out on the ocean collecting data, doing all the stuff with boats, but he actually only spends maybe a few % of his time out in the field, and most of his time he's actually hunched over in front of MATLAB or Python or the command line, programming to process data. So pretty much everyone is doing programming, even things in very physical science fields that you think of. And then there's these things like data visualizations and data graphics and data journalism, as exemplified by sites such as the New York Times. So now with the election underway, national election underway, there's a ton of these election maps and interactive infographics that you can interact with and mouse over and everything. And all of that requires programming skills to put together. So I think this ability to do programming and analyze data is becoming a universal skill across many, many fields. So one of the big questions that drives my research is how can technology make the current generation of data scientists and programmers more productive? And the focus of this talk will be on the second part is how do we train the next generation in a scalable way? So before I talk about training at scale, I want to talk a little about learning just in school. So let's focus on computer programming. So all of your university environments, so if you've taken classes or you've TA'd, this should be intimately familiar to all of you. In school, you can get one-on-one tutoring, right? You can have a TA or your friend go draw diagrams on the board and be in a tutoring session on the whiteboard somewhere in lab and explaining stuff to you in very fine-grained detail. There's a lot of pair programming and peer learning going on. So Leo Porter and colleagues in CSE here kind of pioneered a lot of the work on pair programming and peer learning as applied to computer science. And these are just really effective techniques for learning. So you see people doing pairing here. I mean, you see this in any computer lab in school. All right. And then there's also one-to-many tutoring. So if you're in a big class, you might all be working, say, in the basement of this building on your assignments, and then your TA might go around and monitor what you're all doing and try to jump in to give help. So all of these are hallmarks of a residential educational experience if you're learning, say, programming or computer science. And that's great. I mean, there's still a lot of work to be improved on that. I mean, as class sizes get bigger here and elsewhere, there's a lot of great people working on both research and practice to try to improve the experience of learning programming and computer science in schools, in K-12 and higher ed. And I think this is a really, really important thing because that's where all of you are right now. But I want to look at the flip side of this, which is the fact that the majority of the people who want to learn stuff are not in school, right? So that when we're in a university environment in academia, we're always very school-centric. But if you think about it, most of the people in the world who want to learn anything are not in a school environment. Right, so here's an example of a person who you will meet later. This is Mrs. Hamilton. She is 62 years old. She's currently a document assistant in a law firm, so she's basically a typist. And she wants to learn programming. So she says, I wanted to learn computer programming so as to establish a new career and have some independence. This is someone who's well over 60 who wants to pivot their career with a more technical skill set. But she says the most frustrating aspect of learning online is I do not have a teacher on a face-to-face basis, such as a classroom environment, and this has impeded me greatly. So this sort of sentiment is shared by a lot of people of all age groups who are trying to learn basically anything online, right? That they don't have these nice face-to-face interactions. And the question I want you to think about that I'm going to address in this talk is the following, is how can we scale up the benefits of face-to-face learning to the rest of the world? So how can we take all these great things we know how to do in person and in the classroom and bring it to these millions and millions of people who are not fortunate enough to be in, say, a university environment like this? And I want to start with computer programming because it's a technical prerequisite for a lot of different skills such as data science, data analytics, journalism, as saw in the previous slide. But a lot of these ideas, if we kind of reflect back and then can generalize to other domains as well. So programming is really my substrate for exploring a lot of these ideas. The talk will be organized as a design space exploration. So this is a design at large seminar. So I think this is really awesome that I framed this talk around this design space. So what is a design space? It's a space of possible designs for, say, a technique or a tool. So I always like to draw stuff on two axes because it's hard to comprehend more. So on one axis here, I've chosen the y-axis as fidelity. So fidelity means some kind of notion of realism, right? So people talk about high fidelity prototype versus a low fidelity prototype. It's how real is this interaction, is this thing. And on the x-axis here, I've chosen to put scale. So how much does this technique or tool scale up to, thousands, hundreds of thousands, millions of people? So as with any design space, let's just start at the two extremes. So one extreme here is just face-to-face working together, like you're at university here. It's probably the highest fidelity you can have because you're there with a real live human sitting next to you, can see all your emotions, can customize everything for you. But it's the lowest scale, right? Because you have to grab another person if you want to do anything. On the very, very other end are static online materials. So this would be stuff like reading something off a blog or taking a MOOC, a massive open online course, or downloading some PDF, or even watching a YouTube video. Like all these things scale really well because once the material is online and hosted somewhere, in theory, anyone in the world with internet access can get to it and can learn from it, which is great. But it's very low fidelity, right? You don't get any kind of human support. You're just basically on your own learning, doing the best you can to learn. And what I want to do is I want to, the tools I'm going to present are inspired by the best practices in face-to-face learning. And what I do is I want to try to design these tools for scale from day one to try to overcome some of these limitations of face-to-face learning. And then I'm going to use the scale, to show efficacy of these tools and then to inspire the next step along the line of the story. So this is going to be a pretty kind of broad, breadth-first story of several of these vignettes along this design space. So here's the basic outline of the talk. I'm going to start talking about this platform called Python Tutor that serves as a substrate for a lot of these experimental tools. And I'm going to talk about 3 particular ones. The last one I'm not going to go about in as much detail that are built off of this platform. So first to start, I want to kind of have everyone go back to when they first learned some kind of programming. And it turns out learning programming is really hard, and experts often forget how hard it is because we kind of already know it. So it's hard for many reasons, but one of the simplest ways to boil it down is the following, is that when you're programming, you need to write some code, and usually in some text-based language. So this is Python, but it could be any other language. So for those of you who know Python, you can look at this code and start squinting at it and trying to figure out what it's supposed to do. So when you write the code, you usually compile or interpret or run it, and then the code does something, right? It has some output. So this is a command line program that just runs, prints out 3 lines, X, Y, Z, it prints out the statements. You can imagine running a GUI program or mobile apps and it outputs something graphical, but the simplest ones are command line. So what you have to do as a person learning is you have to form a mental model of what just happened. How did I go from these squiggly letters and characters to doing something to these things popping out? So nothing in here is visible to you. You can only see the inputs and outputs, and you have to infer what just happened to bring what you just did to the output. So here is a mental model where that perfectly explains this pair, right? So this is X is a variable that's a list that points to a list with 3 elements. Y points to a list. The first thing points to the second list. This Z is the same thing as Y. So if you look at this, X prints as ABC, Y prints as this, and then Z prints as that, right? So this is a mental model you could form from studying this piece of code or writing this piece of code. So this is good, except for the fact that it's completely wrong. People turns out they have all sorts of misconceptions about how programming works based on prior knowledge of, say, mathematics or natural language semantics, or just kind of folk knowledge about how they think computers ought to work. And one of my colleagues documented a lot of this in his dissertation. And there's this giant table here, but I'll go into 2 of them. One of them is variable assignment moves a value from variable to another rather than copying it. Another one is kind of objects implicitly have pointers back to what refers to them. So the pointers go both ways, which they don't actually do unless you purposely do that. So there's a lot of these kind of empirically derived misconceptions that beginners have about how code ought to work. And one way to correct these misconceptions that's worked well in practice historically is to create visualizations. So if somehow you're able to visualize that this code actually did this internally, then this is actually the right drawing for Python. So what actually happens is there's a lot of sharing and aliasing going on. So this is what actually happens in the computer. So if you're able to build these mental models, then you're able to just become more adept at programming and debugging. So in sum, these mental models are really foundational prereqs. So as people who already know how to program, we have these in our heads so ingrained that we don't even think about them. Although actually, if you actually quiz students, students who get A+ in the introductory programming classes, if you actually test them afterwards, you'll find a lot of them don't actually have the right mental models, but they're still able to pass the class. Same thing with physics or math. So actually, we think that as experts we have these correct mental models, but a lot of times you can actually get by maybe not having the right ones, but it will get you down the line somewhere when you're doing more complicated tasks. Visualizations can reduce this extraneous cognitive load by looking at visualizations and studying them. It actually helps you to solidify these mental models. And then also it's actually really good to study these pre-made visualizations first before drawing your own. It's called the work example effect, which means that by studying examples of stuff that already exists, you can help form these models in your head. So how do people do this normally, right? People just draw them manually. So you have an instructor here, this is for a Java class, they're just drawing on the board while they're teaching, these arrows and diagrams. There's many, many ways to draw these. So the question I have is, how do we scale this up? Right? How can we scale up the benefits of this face-to-face drawing to everybody in the world? And the specific question here is how can, let me see, my clickers. So how can computers automatically generate these visualizations? And I want to go into this Python Tutor tool that I built up over the past few years that does just that. So you can play with it on the website right now. If it's up, so what it is just a website. So you can just go to pythontutor.com. You can just write code. It's basically like a simple code editor. You can press visualize. There's some options. You can choose languages. So right now it actually is expanded to support a bunch of languages, not just Python. A lot of popular languages for teaching. And once you click the visualize button on the bottom, it sends your code to a server. The server does a bunch of stuff to instrument, to debug, and run your code. And it basically sends back this runtime trace of everything that happened that's relevant to your visualization. And then the front end just generates this interactive visualization that you can play with. So for this simple example we've been doing, when you visualize, it runs on the server. It runs a real version of Python. So it has the real Python semantics. And then when you go here, you can click forward. And then you can see there's this arrow saying this line's about to execute. When you execute it, it'll draw a diagram. So X is a list ABC. And then when you see Y equals X, what happens here, right? So if you don't know Python, it's not exactly clear whether it makes a copy of the list, whether, does Y point to X, does Y and X to the same list, but it actually just, they both point to the same R value. So these are really, really clear once you illustrate it. So this is what is Z equals YDE. Where does the pointers go? It goes like that. And then Y equals Z, just swapping the pointer around. And then when you print, there's a terminal here that prints to. And the trick here is you can go backwards too. And there's actually not a real gimmick here, is because all the stuff is already run and you're just playing with the basically a view of it. These diagrams were inspired mostly by studying how people were actually drawing these things in real life, how they were laying them out. So people, it ends up, because people are pretty constrained on the board or on a whiteboard, you're actually laying out stuff in fairly simple ways. You're not doing some, n-dimensional hypergraph layout or whatever. You're really laying stuff out horizontally in a grid and stuff. So we have some nice, simple layout heuristics to make sure these things look stable. I also studied a bunch of books. So if you just look at programming books, they have all sorts of layouts, horizontal, vertical, nested, some nested data structures and stuff. So that's how I built up kind of the graphical vocabulary or grammar for this. So designing for scale was an important thing about making this tool. So a lot of people have tried to make these sorts of tools in the past, but I think that due to technology limitations, also some kind of design decisions people made in the past, none of these tools have really gotten wide adoption, and I think there's for several reasons. One reason is the fact that the Python Tutor tool came upon a time when the time was just right. So the open web standards were good enough that you can just throw all this in a browser. This is one of the first, I think it's the first tool one of the only ones that's just in the browser, right? Other ones you have to download some software and configure it, have some weird compiler version. No one would actually download it. All right, but once it's on the web, it's so easy. Just go to a URL. No installation. Also, there's no accounts, because I just want anyone to jump in and just start using it. No paywalls, no accounts or anything. There was a URL. So the nice thing about being on the web is that you can actually just create a URL. You can shorten this if you want to, but the URL actually captures all of the state. So then this is a simple idea, but it's really powerful, because you can just send this on a discussion forum. You can send it on Slack. You can send it on IM, send it on email, and your friends see it and they can help you. They can say, oh yeah, I'm on a discussion forum for an online course. This weird piece of code doesn't work on step 5, and the state encapsulates this step. So when they go to this URL, they see the same visualization. They can help you. The really cool thing about this, the effect of this, is that they actually go on the site and they help, and they're like, oh, what is this Python tutor? I'm going to bookmark it. I'm going to use it myself. So URLs are just a great way to virally spread things. Also, you can embed. So again, this is all open web standard. You can generate a little widget that embeds this in somebody else's website. So if you're making a curriculum or a textbook, you can just start snapshotting these and embedding them in your website. So all of these really help it to just grow. And then the last part is I want to be able to add new languages really fast. So I don't have time to go into technical details here, but there is this kind of graphical grammar and modular library and architecture to make it so that it's really fast to add a new language. So I've added a bunch of languages to this beyond Python. I've written most of these myself. Java was actually written by another person who's able to use the API, and it's actually a pretty robust one. And it's at this point, it's fairly trivial to turn the crank to add new languages on demand. But I think these cover most of the ones that people are really caring about at this point for teaching. But the important thing is, this in 5 or 10 years, some other language might come up on this list, and we'll implement it for that, because the framework is pretty general. So this has actually gotten a ton of users in the past few years. So total amount of code visualized, it's in the tens of millions at this point. So every time someone hits visualize, we log all the codes that we can analyze later. This graph is from a year ago. So this is about up to 20 million. And also I only started tracking in 2012. So it started a few years earlier that probably didn't have as much traffic. This is no advertising, right? It's all very naturalistic word of mouth. It's just got another kind of benefit of me making this tool the time I did with Fortuitous Timing is that was when a lot of these massive open online courses started coming up, and programming was a really popular sort of course for these curricula. Other things like Codecademy, Khan Academy all have introductory programming curricula, and it fits really well with this ethos of open web. So like this tool just kind of by verge of kind of designing for the open web and just kind of integrating along with a lot of these other platforms, it just makes it so they grew really rapidly. I think I like even more about than just kind of the raw numbers is just the diversity of the users we get. So we get millions of users we've logged from pretty much every country. So I really like this map, which is showing density by country. This is again by IP address. So it pretty much covers everything except for what you would expect. So Central Africa is there's a big challenge in terms of internet connectivity and technology there. To get further into that, we would need to improve infrastructure-wise. We did a bunch of surveys for demographics. A really cool thing here I found was that about over half the people were over, say, 25 years old. These were not what you think of as college students or kids trying to learn programming. These are adult learners, supposedly with jobs, in different occupations. 1/6 of the people are 55 or older, so they're usually late career or even retired people. So the really cool thing about this platform is people are using it from all walks of life, and it's not just for say college students. So to sum up, I'm going to just go through this really fast, which is people find this valuable for building mental models, right? So people are just talking about step by step. I really wanted to be able to kind of dive into the computer, see how it worked. The second one is for debugging. So people actually just paste in their code for school assignments or stuff. Something is breaking in the terminal, so then I'm going to paste it in and actually really dive inside and really hone down what the error is. So what have we learned? That this idea of surfacing procedural state, of surfacing what is going on step by step when some complex process is running, such as a computer program, is really useful for mental models and for debugging. This idea of designing for scale made it one of the most widely used software projects that I know from an academic lab. And then an obvious line of future work here, which I don't have time to talk about in this particular talk because it's more focused on systems, is thinking about how to use this as an experimental platform, which I think is a really powerful lever now that we have thousands of users per day from all these countries. We can try to measure learning. We can try to, and right now on the site now, if you actually go now, there are various experiments running that I have with colleagues to try to gauge, to try to do different measures of learning, frustration, retention, and such. It's just really become this nice kind of live test bed. So we haven't published those results yet, but we're working on submissions right now on that. Okay, so in the space of learning programming scale, where I would put this Python Tutor tool is basically an improvement on these static online materials, right? So whereas these static online materials are really low fidelity, we now at least start getting a little bit better. We're going to get a little better fidelity. We can peer inside the computer a bit. It still scales pretty much just as well because it's just all automated, right? There's no people involved. You're just basically doing a plus on these static materials. So instead of reading a textbook, you can read a textbook and write some code and see what's going on. But the problem is I still haven't started to address, we're 1/3 or halfway through the talk. I haven't started to address this original problem with no human in the loop, right? What Mrs. Hamilton and people like her want is that she wants a teacher and somebody to help guide her, right? And like these visualization tools are nice to play around with, but you're still on your own. So what can we do about that? So the first tool I'm going to introduce on top of this platform is called Codella, and this is a tool I worked on with several of my master students when I was at Rochester. So the design inspiration came from computer labs, so doing observations in labs just like ones here. And so there's a lot of pair programming and debugging going on. There's a lot of pointing to the screen, right? There's a lot of people just kind of pointing and saying, oh, this is go here, go there. We're discussing things verbally. And then people do draw diagrams as well, right? They take out a scratch paper, they go on the whiteboard. Because again, by default, when you're on the computer, you can't see what's going on. So you have to really make drawings or try to externalize your memory. So again, how can we scale this up? And in this case, how can we bring these in-lab interactions to people who can't meet up face-to-face. We want to do this except for people who are not in, say, a school environment. So to do that, I built this tool called Coachella, and this is the first multi-user visualization of Runtime. It's basically on top of Python Tutor. You'll see it's basically just a multi-user version of Python Tutor. I'm just going to play the demo video. So if you're writing code right here on the site, you can visualize. If you need help, you can do step through. You can press this big red button on the left, and this will generate a unique URL. And then you can paste this URL in for your friend. And then when they join in, they're actually in real time now, right? So you see the cursors, you see each other's cursors and clicking, and you can step through, you can chat with each other. So there's an embedded small chat. And you should be able to edit code as well. So let's try something. So it's like a pair programming environment where you can just edit code. And again, this is all just on the web. You can play with this right now. And then you can execute and see they solve the problem. So the idea is that your motions are all synced up, right? So you have two people here or even more. It's built on top of Python Tutor, so it has all the same nice scalability benefits of being on the same platform. So all of these weird bugs are debugged, so lots of people are using it, so it's really stable at this point. It's basically adding these real-time synchronization abilities to the code and visualization. So it's a really simple idea, but it turns out to work really well. Just like with Python Tutor, joining a session is as simple as a URL. So unlike the sharing URL before I talked about a minute ago, this URL is actually a real-time shared URL. Right? The other one was just like you visit the same web page and you see the same thing. But this one actually you're chatting with each other, you see each other's cursors. The multiple cursors are good to emulate kind of you're there and you're pointing to stuff together. And then the text chat ends up being more scalable than video, both because of bandwidth, because you don't have to have so much bandwidth for video chat, and also because if you're, say, in an online class, you might be okay text chatting or IMing your TA, but being on video is kind of more intimidating for people. So text, we found, is a really lightweight solution for this. Also, text lets you have more people, right? So if you, so this is made either for one-on-one, like this, or small groups. You can actually have 4 or 5 people in the room, and it's just like a, just one cat conversation. You have 4 or 5 mouse pointers and all synced. You probably don't want to have more than that because then you fight over the mouse, right? You're kind of fighting over the cursor. But if you have several people, you can all tune in and say, watch one person demonstrate something, and I'll ask questions. So some questions that we had while doing the experiment is, can they bring these in-lab interactions to people who can't meet face-to-face? And can people actually learn and feel some kind of connection by using it? So we evaluated this by just doing a live deployment for a while. I mean, this has been going on for years, but when we wrote this paper originally, we had about half a year's worth of data, or a year and a half, sorry, worth of data. But it's still being logged now, so we could reanalyze that data for later as well. So all we did was just add a button right here to say start a shared session. There was no advertising. There's an FAQ down here to say what is this thing, but like we didn't do an explicit recruiting for this. We really wanted to see of the thousands of people who are on the Python Tutor site today, naturalistically, would they discover this service? Would they find it valuable? How would they actually end up using it themselves? Right? Like we didn't want to be like, here, we'll pay you $20, go and chat about this programming problem, because then our discovery is, hey, look, people chatted about this programming problem. All right, but we want to see, unprompted, what are people going to do with it? So it turned out that people did end up using it a fair amount with these remote collaborators. So in the data set we had back a year or two ago, there are hundreds of sessions. They span a lot of cities and countries. The significant bit here is that over almost half the sessions were multiple city, which means that they actually were connecting with people that wasn't just their next door neighbor. This was them discovering people somehow that were on another city, maybe another country. This is a map that one of my students made when we analyzed the data. So 2 countries are connected if there was some session where the people came from those countries. So they came from all over the place. And again, we didn't collect detailed demographics on this, but we suspect that how these people found each other were probably taking these MOOCs, these online courses together, maybe posting to Stack Overflow or forums and stuff. And people joined and helped. So the big caveat here is this tool is really just a conduit. You still have to know somebody, right? Like these people had to know each other somehow to like connect to each other to talk. It's really just a substrate. They interacted like in very similar ways that they did in lab that we observed. So there was two main kinds of interactions that were pretty evenly observed. So we just analyzed the chat logs to see the kind of interaction. So this is a tutoring kind of interaction, which is the tutor says kind of the Socratic method of just asking questions, and then this is just the tutor talking. And then the learner, I blanked out. But good tutors would kind of start guiding the learners along and asking them questions and stuff. And the other one was this peer learning where there's a back and forth. There's like, all right, let's try to do our homework together, or let's try to figure out this practice problem together. And you can see them talking back and forth, and their level of knowledge was fairly similar. And we have a lot more chat logs now that I haven't had time to analyze. But people actually learn mostly by discussing these visualizations. So it's like the question here is, why do they need these visualizations? Why don't they just like go in a chat room together? And that might have a reasonable effect. But it turned out that when we actually looked at the logs, the sessions were actually pretty long. The median was 42 minutes. So this is like as long as an in-person session. And there's a lot of visualization interactions interspersed. This doesn't show this, but they are chatting and then visualizing and chatting and visualizing. They're not just going in it as a chat room without doing anything. The chat log showed both kinds of transfer of knowledge. So declarative means what is this syntax, or how do I do this? Sorry, the procedural means how do I do this step by step. At the what's called the lower 3 levels of Bloom's taxonomy. So Bloom's taxonomy is this 6-layered thing that is kind of knowledge transfer and how sophisticated it is. So with the bottom being kind of rote knowledge, kind of like, did you remember the syntax for add or looping? And then the top one is, can you synthesize and create brand new knowledge? So we observe in the chat logs interactions of the bottom 3 sorts of learning. And these are often anchored to the visualization. So here's an example quote of like, they're actually talking about the thing they're visualizing. So a lot of this happens. So it wasn't just like, how do I solve this problem? It was, let's go in, let's play with this visualization, and now let's just talk about it. And we actually see, remember there was the mouse cursors too. So people were just like going around and pointing to it and say, look, this thing here is now pointing to this other thing. And if you notice, this quote is confusing on purpose, because if you're just looking at this quote without a visualization, without any context, it's hard to figure out what's going on. Like there's no context. But if you're actually in the visualization, I'm sure these people figured out what was going on. People also bonded emotionally. So I didn't do a ton of detail analysis on this, but we just saw a lot of these exchanges that promoted motivation. So banter, kind of friendly talking, camaraderie, encouragement. So learner says, oh my God, and then the tutor says, not a problem, you've written little code, it'll take a while to get it. So we saw a lot of these sort of more humanizing interactions, which is cool to see, that it was very much not like a Stack Overflow or a discussion forum where it's like, give me your question, give me your answer, right? So Stack Overflow is in contrast explicitly designed to be unemotional and Vulcan-like, right? You're supposed to just get right to the point of the question, get right to the point of the answer, no extraneous anything, because it's supposed to be like a dictionary or a reference or an API reference. But this, these sorts of interactions we found were really interesting. And if people want to talk to me about this work, there is a ton more data now, and I don't have enough bandwidth to analyze it all, but I think we can go a lot deeper in figuring out the discourse of a lot of these things and figure out maybe we can develop bots or conversation agents to help in that. Okay, so summary of Coachella. So we learned that a substrate for discussing procedural state is effective for people who can't have in person. So this is, we have procedural state, we have the step-by-step what's going on. If you just add in a really thin layer where you can just talk about it, it turns out people actually use it and it's actually fairly effective. This is a paper I really like by Jim, who was in the back. So Jim wrote this paper when he was at Belcore, when he was leading a team there, called Beyond Being There. It's a classic HCI paper which just talks about how when you're building user interfaces and computer-based tools, you want to try to strive for an interaction that is even perhaps beyond or better than being there in real life, rather than just trying to emulate real life. And it turns out that in 35% of the sessions, so over a third of the sessions, people use Coachella in settings where they were taking a class together. And we got this indicator by just seeing the chat logs that they were just talking about their class, or talking about what they're going to have for lunch, or talking about, where they're going to hang out with each other afterward. And we thought this was really interesting because, they could have just gone and hung out with each other, or just chat on the phone or something, or an IM, but they still chose to use this tool, even if they were physically able to be in the same place. And I hypothesize that some of the reasons for that, beyond being their effect here, is that this is a really lightweight interface. This doesn't involve video. You can multitask in the background while you're doing this. It's just a really lightweight way to interact, and even by students who could be in the same place supposedly. And finally, these effective, these meaning emotional exchanges, humanize this aspect of online learning, which is cool to see. That it was that people actually went in encouragement, they got frustrated. These are actual human beings behind the scenes. They're not just robots giving advice. So this gives me, as a human-computer interaction person, this gives me more motivation and inspiration that designing these tools to help people connect with each other is really essential, and not just having a bot tell you exactly what to do, because you're probably not going to be that motivated knowing that it's a machine telling you these things, even though it may scale better. So in the design space here, where I put Coachella is here. So we are going from face-to-face to one-on-one tutoring or small group tutoring, but a bit more scalable, right? So you're scaling a little bit more because you don't have to be there in the same place, but it's a little lower fidelity, obviously, because you don't have full human interaction. You're just interacting through an app. So one problem here that we discovered while working on this tool, which is an obvious one in hindsight, is that there are much fewer tutors than learners. So we found that there's a lot of people who want to learn in any environment, but there's not a lot of people who can be experts enough to tutor. So an example here is Mrs. Hamilton in a MOOC might find this tool really useful because she can go send a URL and post on the forum or on Slack on a message and say, I need help in this, can someone help me? And then a tutor can hopefully jump in. The tutor in the MOOC can hopefully jump in and help her out. And this is a good interaction for the learner, for Mrs. Hamilton, but it may be hard for the tutor because the tutor might have a bunch of people like her asking for help at around the same time. There may be 5 students asking for help, 10 students asking for help, 20 students asking for help. So what is the tutor going to do? They have to open like 20 tabs and like go between them and everything, right? Like each tab takes up all of their bandwidth, visually. So how can they help more than one person at once? So the bottleneck here is really the tutor and not the learner, right? So how can a single tutor help more people at once? And that's the subject of the second system I'm going to present, which is called Codopticon. So you have one tutor in the middle here. So this is a bunch of peers, and this is one tutor in the middle, and there's a bunch of learners that they're trying to help. Again, we went back to the lab for inspiration, this time to observe the teaching assistants. So a teaching assistant or instructor might be walking around monitoring, say, 20 people at once or so. The ideal thing you'd want is timely, targeted, and proactive help. So timely means someone has a problem, you can jump in right away. That's why they're in lab working and they're not at home, right? They can just raise their hand right away. Targeted means that you're an actual person and you can help them, with what they need help on, and not just giving a standard Google, whatever Google search comes up or Stack Overflow shows up. You actually customizing your help. And proactive is really important. Proactive means that you can actually monitor to see when someone might be struggling, and then jump in and offer, say, a nudge, saying, "Oh, do you need help on this?" Or "It looks like you've been stuck for a while. What do you think we should do here?" And proactive is really important, especially for more shy students or more novice students who may not want to, say, bother the TA to ask for help. So you may get students who are just stuck forever unless you actually go up to them and give them a friendly nudge. In reality, you have, say, 20-to-1 ratio. You have 20 students in a lab, maybe more in a bigger lab. And it's a best effort scramble. Like, they just are running around trying to scramble. And it's really exhausting as well, right? So just the physical aspect, even forgetting the mental aspect, the physical aspect of running around a lab for an hour is pretty tiring. So how can a single tutor help more learners at once without, say, as much fatigue? And the approach I took here is that not only do I care about this in a setting, in a physical setting, it'd be great to build a tool to help the TA triage and help people in the lab, but I want to think even bigger in how can we scale this up so that it helps everybody in the world, right? We want to design the single tool that helps both people in person and people in, say, a remote setting. So, if you're taking a MOOC, and Mrs. Hamilton taking one of these MOOCs, how can we build a system that helps people in a MOOC as well as in an in-person class? So the basic idea behind Codopticon is the following, is that you have a tutor here in the middle, and you have a bunch of learners who are writing code, all around them conceptually, and it's a one-to-many interface. So what that means is that you are watching a bunch of people code at once, just like the TA is, and then you can jump in to help anyone you want. So to start illustrating this, I'm going to give a really simple case of whether you have one learner on the left here and the one tutor watching them. So this is a one, imagine you have one learner. So the left side of your screen is the learner coding. So they're coding on Python Tutor or any other education site. And the right side is the tutor's view. So this video will play twice. So the first time the learner is writing a function in Python, product, this could be anything, right? Any IDE or website. Let's do it A, B, instead of X, Y. So we're going to return a XB, right? That's product. That's the multiplication sign, which is an X symbol. So they do this, and they get some weird error. They don't get what's going on. And then they change it to a lowercase x, and then something else going on. Okay, same video. Now look at the right side, which is what the tutor sees. So the exact same program is playing. The tutor sees these edits come in chunks. So it's green for addition, and then flashing red for deletion. So this is deleting code, and then red is addition again. This is all in real time. These chunks are useful so that you just see kind of tokens at once. And then when they try to run, you see their error right there, like syntax error. You see the exact same error message in real time. And then they delete, and then they run again, and then error. And then now the tutor has a whole history of the whole process, right? They can go backwards and forward to see what the learner was struggling. It's like, how did they get here? And then they can start a chat with any of the learners. So they can open the chat box, and then it pops up a chat just like the previous tool, just like the Coachella tool. And then you can ask them things and stuff. And then the chat for the tutor is kind of small. But then, yeah, it's this. If only all tutoring sessions went this smoothly. It's quite a canned example. But so the basic idea there is that you have the tutor has a view of each learner that's just a summary. So it has a slider that shows all the edits they made. It has a little chat box that you can go and chat with the learner. It has all their code and how they're editing it. This is one person. So how does it scale up to multiple people? So it's just a pretty simple grid interface. So it is so this is just on the web. So each learner has its own tile. So if you were to play a video of this, you would see all the learners would be editing, and you can kind of monitor. It's kind of like a security camera in a way that you can kind of just see what everyone in your class is doing in real time. And then you can open up any of these chat boxes to talk to them as needed. The thing Dev says here, it's not like I'm expecting anyone to look at all 10 simultaneously. I just want to be able to surface everybody's stuff so that you can potentially switch your glance around and look at it. You're still limited by your own attention, right? You can't help 10 people at once. I don't think anyone can. How do we design for scale here? The first part is about, it plugs into any kind of web-based coding environment like Python Tutor, because it's all standard web stack stuff. As long as your environment supports streaming this data in real time in two ways, you can just plug it in. There's a history slider to get context. So you can imagine that if you are watching 10 people code, you're going to miss something, right? Like you see them getting a funky error, then all you have to do is just slide the slider back a few steps, and you see, oh yeah, they had this common error. You can do multiple text chats. So the reason why I put these tiles so relatively small is because I want you to be able to open multiple chat windows and to talk to multiple people at the same time. This is key because you can actually scale up better than you think, because a lot of students are not going to be that active, right? So you're giving someone a piece, if you imagine you're a TA walking around a room, you want to give someone a piece of advice, have them run with it for a bit, or ask them a question, and then you can go switch to someone else and help them. So it's nice to be able to see all the chats at once. So when you chat with this person, they'll blink when they chat, when they respond to you, you can go help this other person, and then you can kind of go back and forth. An obvious issue is, what if there's more than 10 people, right? So this table has 10 things. If you have a giant monitor, you might be able to fit 15 things. That's great if you only have 15 students in your class, but if you have 100 or 200, what do you do? It turns out that most people are not that active, right? At any given point, only some people are struggling with errors and stuff. A lot of people are staring at the problem. So we have this dynamic algorithm that reshuffles these tiles periodically and kind of pushes up the people who seem to be having trouble in the short term. And the paper goes into a bit more detail on that. But the idea is that it's kind of moving, and you can lock pieces down so that if you're watching someone, you don't want them to move right under your feet. So it turns out that this can support, say, 100 people, because only maybe 10 are doing something at once out of the 100. And then maybe they go away and there's another 10 that do a bunch of stuff. Questions here is how many learners can a single tutor handle? I mean, this is the big question here. Like, given this interface, can a person handle 3 people, 10 people, 100 people? Can they actually help learners by using this? And then how does Code Optimum compare to just doing a real life tutoring scenario? So to evaluate this, I took a slightly different approach. I did a lab study, but it was also an online study. It was kind of a hybrid. So in the lab, I brought in tutors. So the main target of this tool is tutors themselves, right? So this is a interface for people who are giving help. So I wanted to make sure they were in labs so we can observe them, interview them, and so forth. So this was the instructor and 7 of the TAs from an intro course at Rochester, which is in Python. And this was their first time using the tool. They've never seen this before. I gave them a little tutorial on it, and I just said spend 30 minutes helping these learners on the Python Tutor site in whatever way you feel most comfortable. So they're on the site, they have a banner that says, look, you're being monitored now for using the site, like don't type in your credit card or whatever. They should never do that anyways, because we always tell them your code is being tracked and logged and analyzed, so don't put in any private data whatsoever onto the site. You should not do that on most sites, actually. The text boxes on the internet, you should not just put private data on. So online learners knew they were being monitored, but they were not expecting this pop-up help, right? They were not because most of the time there was no TA, so there would be no pop-up help. So this was simulating kind of a worst case scenario in a way, right? Because this is a pretty hard test of effectiveness because, first of all, the people had never used the tool before. The learners weren't really expecting the TAs to help because they didn't know when the TAs were coming. If we deployed this in a real course, whether here at UCSD or in a massive online course, the TAs would be trained. They would know how to use this tool much better. And the students would know that, if you consent to taking this class and using this tool, your TA may help you. Your TA might have an office hour, 3 to 4 p.m. These 3 TAs are online. You see their screen names or whatever, then they might be able to help you. So even in this in the wild case, let's see what happened. So what did the tutors do and how do they feel about it? So they managed, on average, each session had about 200 people coming in and out during 30 minutes, actually. So it was pretty heavily trafficked. There's about 52 online at once. So at any given time, the traffic goes up and down. There's around a few dozen people. The first indicator from the tutors that this was actually a cool interface for them was that there's this immersion effect. So pretty much everybody went over the time limit. Like they wanted to keep going and working with it, even though they didn't have to. They didn't show any visible signs of fatigue or overload. Again, we did not strap stuff onto their brains to measure brain waves, but they seemed to keep on wanting to go right at that time. That it was a lightweight enough interface that like they could just watch and type a few words, and they weren't like typing furiously for all 30 minutes, obviously. Right? They were kind of watching and waiting. They did a lot of scanning and selective attending, so as expected, they're not going to help everybody all at once, right? Because they're kind of picking their way around and seeing who needs help or kind of gauging, just like they would in a real classroom. Right? You're not expecting a real life TA to help everybody. They're having to scan themselves. They reported this authenticity. So a lot of them reported this was like tutoring in real life. So they had their true personality showing and their own personal styles, even if it was just this canned text-based interface, which was surprisingly refreshing. So some people, even though there was nothing at stake, these people were all anonymous, no one knew who they were, they still wanted to feel like they were tutoring in the right way according to their personality. How did this compare to in-person tutoring? They reported advantages. So this is again from the TA's experience. The big advantage is they can control their own pace. They said that in the lab, if they're going around, they're being pulled in all directions, everyone's raising their hand, they feel really bad about neglecting one person or something. But if they're in control of the dashboard, they can be okay just saying, oh, hold on, I got to help someone else right now. And they don't seem like they're as pressured. The history slider works really well. This is a beyond being there. It's better than real life, or you can kind of go back in time. And it turns out that they help around 3 people once. So the answer to the original question was they can multitask about 3 people at once. This is the number of people they're chatting with at any given time. So it goes up and down. Some people chat with more, some people with less, but around the average hovers around 3. So it takes people a while to ramp up to find their first person to help. And then they're usually having several conversations at once. Not too many though. Disadvantages? People widely reported the text was a bit too low bandwidth, right? They had these little text boxes. They really wanted to chat more in detail. But the design of this was that we wanted to be able to scale this up. So each individual person, you can't obviously chat in a ton of detail. Also, they realized that the reshuffling algorithm is benefiting people that are more active, right? So if you're just stuck and not doing anything, we don't know remotely whether you're surfing Facebook or YouTube or you're actually really frustrated and stuck. So one easy way to alleviate this in the future is you can put like a get help button. So it's like, I'm really stuck, I really need help, can you prioritize me and put me on a queue? But without that, people were afraid that they actually scanned down to look at the stuck people because they were afraid that they were just stuck for some reason. Even though in our prototype, we have no way of knowing what they're actually doing on the computer. Okay. So to wrap up, how do the learners react? Again, we analyze the chat logs. We don't know the learner, so we can't get their actual interactions. So we just have to approximate by analyzing the chat logs. In each 30-minute session, about 2 to 3 learners confirm that they got successfully helped. This is, again, despite this being completely unsolicited. This is like a customer service site where someone pops up and says, do you want to buy these kinds of shoes? Where most people just shut the box down. And when they closed the box, we told them not to bother this person again. But despite this being completely unsolicited, several people actually reported they got help successfully, which is, I think this ratio is almost as good as I would say, to expect of a real life session, 30 minutes, helping several people is pretty good. And if you're trained, you can probably help more. Both kinds of knowledge were transferred again, just from a chat log, this time at the lower 2 levels of Bloom's taxonomy. So here's some examples of concepts that are transferred. Again, this sort of chat is really more for the debugging and getting you unstuck, sort of really low-level code chat. It's not about like, how do we design our system? Because, or philosophies of software engineering or something. It's really about, I'm stuck, I'm really debugging something low level. So summary. This is the first one-to-many system. It can help around, it can scale people up to about 3 at once. The important thing though is that you can monitor a few dozen people, right? Maybe even 100, to try to find those few who need help. Whereas with the old interface, you can only monitor 1 at most, right, or 2. This is immersive, authentic, and this like beyond being there. People actually preferred this over in lab tutoring. So this may have been a function of being in Rochester, but everyone was like, I do not want to go to the computer lab in the snow because it's snowing like half the year. I would actually want to do this for my real class, right? Even in a real class that I'm TAing or teaching, I would love to have this dashboard in my home and just do this because I don't want to trudge all the way in the lab and help these people out in the lab. So this is a cool beyond being there point. And this idea of process history makes it easy to help multiple people at once. So just by seeing the history, people actually use the history a lot. So that's one way to scale up in space because you're not going to catch everybody's action. You can't see what 10 people are doing at once. So you can just go back in time. Okay, so to wrap up, what Code-Opticon does is push the scale even more, right? So from 1-to-1 to 1-to-many. And this, again, it's lower fidelity. It's not as good as Coachella. We don't have all the visualizations, all the details. But it scales up more because you can get 1 to a few dozen people. But the last problem that I'm going to go into ongoing future work, so what if there are no tutors, right? So both Coachella and Code-Opticon assume that we have some tutor or expert available to help you. We might give them a helping hand to scale them up. But if there are no tutors, we can rely on learners themselves to maybe help each other. So this is kind of a crowd of learners. This is a project, one of the projects I did with my undergrad at Rochester, Mitchell Gordon, who's now, he's just started his PhD at Stanford. So he also escaped the snow and moved to the West Coast along with me. My other undergrad, Jeremy Warner, he started at Berkeley for his PhD. And then I had another undergrad who went to the Bay Area. So we basically all got out of the snow at the exact same time. I think they all followed me. It's a mass migration. So if there are no tutors, what do? You can summon your fellow learners. So here is a traffic log of how many people are on the site at once. So it hovers around a few dozen, it goes up and down with the days. But at any time, if you're on the site or on a MOOC or anything, there are dozens of other people on the site doing similar things as you are, but you're not seeing each other. So what can you do with that? So what Mitchell's project was for his undergrad project that we actually published was, can we get the crowd to create tutorials? So can we pose a question to the crowd, say, how does this code work? Or I'm stuck on this thing. Can we farm this out to the crowd, have them actually visualize the code using the Python Tutor, and start putting annotations on what each line does? They're trying to explain things. And then they can do the usual crowdsourcing things of voting on each other's annotations, correcting each other's annotations and stuff, and come up with some kind of coherent tutorial. Turns out this works reasonably well for simple code, but we did a really simple first approach, and I think there's a lot of ways you can improve that. The main way you can improve this is latency, is real time. This takes forever because people aren't that motivated. I mean, we're not paying them, they're just kind of doing it on their own will. It may be good for a tutorial you make over a few days, but it's like, if you need help right now, we really need a way to match people up or to give people visibility in what each other is doing, so that you can actually match yourself up or say, look, these 5 people are also working on, you're also working on linked lists. Do you want to maybe get together with them and work? And again, we have to really take privacy and all these intents into account. Right? We don't want to just randomly do a chat roulette thing and just like throw people in the room with each other without them knowing each other, because that could result in lots of obscenities. But can we build an interface where we use some kind of machine learning, but also some kind of a monitoring interface like CodeOpticon to say, if you're opting into this and you want to pretend like we're in a group setting and you want to let other people look over your shoulder, can we get your permission to do that? And if so, maybe someone will jump in to offer some advice for you to help, or you can connect together to help. So I think there's a lot of potential in this area of real-time kind of help. And what this gets at is it scales up even more, right? So we get to many-to-many with the code free system, with crowdsourcing, and also with a real-time help in the future. It says lower fidelity. I mean, these are not experts. These are crowds of learners. But that's the best you can do if you want to scale up, right? I mean, like, you just don't have that many experts. So as you go down this chain, we would love to be up here, but I don't know, what magical solution we have. So this idea of this design space I want to lay out in this talk is to give people like Mrs. Hamilton more options, right? So she can read from a book, she can visualize stuff, she can try to get face-to-face help if she can find somebody, but in the middle here in this whole continuum, I want to try to lay out some tools that people like her can use for learning online. So in the minute I have to wrap up, I'm going to just reflect a bit on the kind of the main theme that I've demonstrated in this talk. And the question we came to when starting this talk is, how do we scale this up? And the approach that I took was by surfacing this hidden procedural state and process history, which is what is going on inside of some complex system, inside the computer, inside the compiler, the interpreter, and the history. How are you editing this? What are you doing when you're doing this programming process, and then just letting people monitor each other and chat with each other. And by doing this, it turns out that it's actually, we've shown empirically that it's been fairly effective at scaling up this learning. And the tagline that I like to use for this is surface then visible, then talk about it. So just be able to surface what's there behind the scenes, and then let people actually talk about it and discuss it in a meaningful way. And I think that this has applications in a lot of areas, and this is some of the areas I'm actually pursuing right now. So current directions are doing data analysis, making data visualizations, developing for the web. There's a lot of hidden state dependencies. Setting up software, right? Anyone who's tried to set up software knows that it's really hairy, doing system administration. All of this stuff is filled with invisible state. All of these domains are loaded with these hidden state dependencies and histories. I think by capturing these and exposing them in the similar ways I've done for basic programming, we can actually really just help novices learn in a more scalable way. So in sum, thinking about all of these domains that programming and data science can be relevant for, in the next 5, 10, maybe even 20 years, what I really hope to do is to keep, pushing on these technologies to train the next generation, right? Because we have a lot of great people working on tools to make experts more productive today. One of the things I'm really interested in is thinking, if we're always thinking about the future, on the next steps, I think a really powerful domain for tools is how do we train people, and how do we train people at scale, right? We know how to train people. If everyone has their own personal tutor, great, but most people cannot afford that. So with that, I would love to take questions and leave the design space slide up here. So thank you very much.